so let us look at 2000 number 2. So it says two runners, A and B, run on the straight racetrack. So for t goes from 0 through 10. And then graph above, this one, is actually for runner A. And velocity in meters per second for runner B is given by this equation. Alrighty. Now, first what they want you to do is find the velocity of runner A and the velocity of runner B at when t is equal to 2 seconds. And then they want you to indicate the unit of measures. So then in case of runner A, I'm going to write down the answer here. Velocity for A is, when I'm looking to this right over here, so that's the value that I'm looking at. But it's kind of hard to tell graphically. To be more precise, what I need you to do is I need you to come up with an equation and then figure out what the value should be. Since I realize that the my initial value was a 0, 0, and then 3, 10, so equation of this line, which is V is equal to 10 over 3. That's the slope, t. So when t is equal to 2, we get to realize the velocity would be 20 over 3, and they told us that actually meters per second is the unit. How about the velocity for B? Let me call it B this way. I'm going to change A with the capital A. All I have to do is plug in the value of 2 in this equation. So we get 48 over 7 meters per second. Alrighty, so we got the value for first 2. Now, let's look at part B. Find the acceleration of the runner A and the acceleration of runner B. Acceleration of runner A is a derivative of the velocity A. So what's the derivative of this one? This will be 10 over 3. And then they want you to indicate the unit of measures. So it's going to be meters per second square. How about the acceleration of B? That would be equal to, yes, derivative of the velocity B, which I can use the calculator for this question. So why don't I do that? So I'm going to type in x . 24, so I'm going to do alpha here. So 24x over 2x plus 3. That's my equation. So then here I want to figure out the derivative. So then what I'm going to do is math number 8 and div against x and alpha trace, because I put it in y sub 1, put that in, and x was equal to 2. Then I get to realize that 1.469. So I'll be getting 1.469 meters per second squared. That would be my answer. Let's look at part C. Find the total distance run by the runner A and total distance run by runner B. Now, in this case, we have to use the integral because velocity is given. But notice that what they said was total distance. While the function is always positive, distance and displacement, they will be the same. But if the velocity function sometimes is positive and sometimes negative, then we need to be careful about those two things. So for A, distance A, I realize that everything is positive here. So all I have to do is find the area under this function. So then is equal to, from 0 through 10, velocity A of t dt. And I realize the first one, I'm going to put that as a triangle. So 3 times 10 divided by 2, which becomes 15. And second one is 3 through 10, which is 7 units. And height is 10, so we get 70. So total 85 is what I'm getting for the runner A. And for the runner B, before I calculate, what I'm going to do is this. I'm going to try to sketch the graph and then make sure that my equation that I typed in here is always positive. Then in that case, I don't have to use the absolute value for distance. So what I'm going to do is I'm going to set a zoom, actually window, because I'm looking at 0 through 10, I'm going to go from -1 to 11. Just go beyond what's actually necessary. And then what I'm going to do is I'm going to do zoom fit. What zoom fit does is that it keeps the x value as I just typed in, and then but changes the y window automatically so that it will give me the best picture. So I'm going to do that right now. Zoom fit. Then you can see that it's always positive when t goes from 0 through 10, because I originally did up to 11. So what I'm going to do is, since it's always positive, what I'm going to do here is I'm going to get the integration. So math, number 9, going from 0 to 10 of dy sub 1, and then dx. Then that should give us the total distance, which is 83.336. Zero to 10. dt is what? 83.336 meters. All right, so that's basically what we can do. Alrighty, so then let's move on to the next question.